Hello everyone. Today we will be presenting a project titled Multimeter Stimulator using object-oriented programming in Java. My name is Janvi and today with Abhinav we worked on this project to stimulate the functionalities of a digital multimeter using object-oriented programming concepts in Java. Introduction. Objective. Our objective with this project was to stimulate a digital multimeter using object-oriented programming. But first, what exactly is a multimeter? A multimeter is a device used to measure various electrical properties such as voltage, current, and resistance. We choose this project to gain a better understanding of how a real world electronic device works by breaking it down and stimulating its functionality using object oriented principles. OOP concepts applied. We applied various key object oriented programming concepts like encapsulation. We encapsulated data like voltage, current, and resistance into classes. Inheritance. We created a general class for measurement devices and our multimeter inherited its own features. Polymorphism. Our functions like measure voltage, measure current, and measure distance behave differently depending on the input. Interface. We used a measurable interface to enforce the implementation of these measurement methods across our classes. Project design. Now let's talk about the design. We constructed a project using the following classes. The multimeter class holds attributes like voltage, current, and resistance, and methods such as measure voltage, measure current, and measure resistance. The device class acts as the general class for any measurement devices. And finally, the measurable interface ensures that the measure methods are implemented across the classes. The flow of the project is very simple. The user input values and the system stimulates the measurements.
Hello everyone, myself Abhinav Suresh. I'm going to explain the further part of this presentation, code implementation. Here are a few key code snippets. Multimeter is a class that implements an interface called measurable. This is a typical of object-oriented design, where a class implements an interface to ensure it provides specific functionalities. Attributes. Voltage is a private attribute representing the voltage values the multimeter can measure. Other attributes like current could also be added based on the methods. Measure voltage. This method could contain the logics for simulating or calculating the voltage measurements. Measure currents. This method could contain logics for simulating and calculating current measurements. Both methods are placeholders with the comments including and indicating where the actual measurement logic would go. The main program flow. In the main program, the user might be prompted to input values like expected voltage and current to simulate a real measurement scenario. The input value could be passed into these relevant methods in the multimeter classes to simulate the measurement process. Finally, now let's execute this code. Here we can input the DC voltage, AC voltage, and the resistance ohms value. We got the output. Here we could see the DC voltage, AC current, and the resistance value. Conclusions and future works. To consider, we successfully stimulated a digital multimeter using OOPS concept in Java, applying encapsulation, inheritance, and interfaces efficiently. In the future, we plan to extend the project by adding features like frequency measurements, improving the GUI using the Java effects and swing, and enhancing the accuracy by handling the real world data. So that's all from our side. Thank you so much. Thank you so much, everyone.